This is your 8.1 and 8.2 notes. I will not do the whole thing at one sitting. So 8.1 will be the first video, and we will pick back on 8.2 on another day. But this worksheet we have for both 8.1 and 8.2. Here we will be talking about the polar coordinates. The polar coordinate system is especially used in modeling circular motion. Instead of x and y in the Cartesian or rectangular system, we will graph it in terms of r, which is the radius, and theta, which is the angle measured. Let's start by identifying a few elements in this polar coordinate. The red dot that I have on my paper here represent my pole. So red here is actually the pole. And this is the polar axis. The x-axis is called the polar axis. Let's go ahead and try to plot point 230. In order for you to plot point 230, figure out first where angle 30 will be located. Of course, in the first quadrant, and it will land on this line. Now, after locating the angle, go ahead and count 2 units. If it's positive, you go outward. If it's negative, you go inward somewhat. You will understand the outward and inward later on. So, because it's 2 units from the pole, I will count 1, 2. If it was negative, it would have not landed on this blue dot, but it would have been on the opposite dot, meaning somewhere here where I'm putting an X. Matter of fact, there's an example of a negative one. Example 2 says negative 2, 210. The first thing I will do is, from my pole, I will locate angle 210, located in the third quadrant, which is here. And from here, I know I will count 2 units, not towards, not outward, not this way, but the opposite way. That's how I end at this location. Note that both coordinates ends up at the same point. There are infinitely many coordinates for each point in the polar system, meaning for this point, I have infinitely many coordinates. All right, in order for us to complete this exercise, the next exercise, let's go ahead and have a quick refresher about our unit circle. The most obvious point on your unit circle, of course, is the location of 0. So I'll go ahead and put 0 here. But 0 is also 2 pi. The next obvious point on the unit circle is the point pi. And pi can be plus or minus pi, but I'll leave it as pi. Halfway between 0 and pi, I have pi over 2. Across from this, I have my 3 pi over 2. Let's go ahead and quickly fill up the rest. I will divide those by 4 to get my pi over 4 here. I'm dividing the pi now by 4. So this is pi over 4. 0, 1 pi over 4, 2 pi over 4, 3 pi over 4 will land here. 4 pi over 4, 5 pi over 4 will be here. 6 pi over 4, of course, is simplified to 3 pi over 4. And 7 pi over 4 will be here. After the pi over 4s, let's go ahead and try to plug in the pi over 3s. The pi over 3 will be, the first pi over 3 will be somewhere here. That's 1 pi over 3. This one will be your 2 pi over 3. 3 pi over 3 will land at pi. Now the next one will be here, and it will be 4 pi over 3. And you have another one here that will be 5 pi over 3. And this is your 6 pi over 3. And the last one will be my, I'll make it, why not purple? The last one will be my pi over 6. So I have 1 pi over 6 here. 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and here will be my 7 pi over 6, 8 pi over 6 is here, 9 pi over 6, 10 pi over 6, 11 pi over 6 will be here, and of course 12 pi over 6. I hope you remember every single thing about your unit circle. Now that we graphed it, let's go ahead and start with the 3 pi over 4. Because it ends in 4, I'll go ahead and use the blue one for that. 3 pi over 4. Well, 3 pi over 4 is located on this line. On this line that I'm making a little darker. That's where my 3 pi over 4 is located. So let's go ahead and now figure out 2 units outwards. So it's going to be located right here. And that point is the point 4A. Alright, let's do the same thing. By the way, I marked A with the blue. Let's do B now. Let's do C. And I'm doing C with a red. C is located at 3 pi over 2 or at negative 3 pi over 2. So from 0, here is negative pi over 2, negative 2 pi over 2. My negative 3 pi over 2 will be here at the same location as pi over 2. So this is also equal to negative 3 pi over 2. Now that I know that negative 3 pi over 2 is located here, so what I will do is I will once again draw this line. It's going to be located on this line. That's my negative 3 pi over 2. From here, I will go ahead and graph it 5 units outwards. So 5 units out will be 1, 2, 3, 4, 5. It will be located here. And this is, maybe I need a different color. This point, I made it purple now. This point is the point C. Let's do the same thing now for E. I'm at 11 pi over 6. 11 pi over 6, where is it located? The first thing I would do, just like I did on the previous one, I would graph the angle 11 pi over 6. Well, 1 pi over 6, 2 pi over 6, 3, 4. If you count, here's your 7, and here's 11. So it's located on this yellow line. So now that I located my, let me change this color to something different. I'll make it this different color anyways. Now I located 11 pi over 6, and it's 1 unit outward. Outward would be this way. So it's going to be located on this point, and I will call that point E. We do the same for B, D, and F. So I actually want you to work on it. I'll pause this, and next time I start recording again, I will show you the answer. So start plotting the point yourself. All right, I hope you were able to graph all the points. For B, it says negative 3 pi over 3. I located pi over 3, and it's graphed in blue on my graph. And pi over 3, since it's on this line and I'm going negative 3, I cannot go towards the location where I wrote pi over 3. I go backward. That's how I ended up with this blue dot. I mean, this yellow dot where I have B. If you can't see it, I'm pointing at it. For D is 2 pi over 3. 2 pi over 3 is located on this line, sort of green, or green bluish. Now you're going negative 5, so you're going to go opposite. Instead of going outward like this, you're going to go back this way, and I count 5. That's how I got my D. And for the last one, which is F, I counted negative 7 pi over 6. You got to count this way, clockwise. This is pi. Normally 7 pi over 6 is here. That means negative 7 pi over 6 will be at the same location as the 5 pi over 6. So knowing that it's going to be on this kind of orange line on my graph, you got to go 4 units, not to work on that orange line, but on the opposite side. That's how I got my F. All right, I hope you understand how to plug in now points. Let's go further and find 3 sets of polar coordinates for the point 2 to 5 pi over 6, and we want it between negative 2 pi and 2 pi. Now the first thing is 2 is in case you go toward the 5 pi over 6. What if you go away from the 5 pi over 6? It means that you need to be at negative 2. Going away, it means that you started at an angle of 11 pi over 6. In other words, if I say 11 pi over 6 and I say -2, you will end up at the same location. I can give you another one. Another one would be, instead of 11 pi over 6, a coterminal of 11 pi over 6 is actually negative pi. I'll still say -2, and that would be negative pi over 6, because negative pi over 6 and 11 pi over 6 are coterminal. Same thing with 5 pi over 6. Instead of saying 5 pi over 6, I can call the 5 pi over 6 -7 pi over 6. And if I call, since they are coterminal, I can just say 2 as well. Those are three different ones that are the same as 2 5 pi over 6. Example 1. This time, we're trying to convert between Cartesian and polar coordinates. In other words, we're trying to find the exact value. I will show you first how to do it by graphing, and knowing how to do it by graphing or by doing your all student take calculus will allow you to memorize few formulas. So 7 pi over 6, 7 pi over 6. What quadrant is it located in? Obviously, it's located in my third quadrant. So I will graph the angle here in my third quadrant, and this one represent my R, and this one represent my angle. R is the hypotenuse here, which is 4. 7 pi over 6, the reference angle is 30. Across from 30, I got 1. And adjacent to 30, I have my square root. If this is 1, this is my square root of 3, normally. But because this is 4, that means this is 2 square root of 3, and this is 2. Remember, your 30, 60, 90 says x square root of 3, and 2x. Here, my 2x is equal to 4, so x is equal to 2. That's how I got the 2 square root of 3 and the 2. Now, the position tells me all students take calculus. The only thing that is positive in this one is the tangent. Everything else must be negative. Or you just look at it. It's going down, negative. Going to the left, negative. The hypotenuse is always positive. So, at this point, one thing you need to understand is, in order for you to find the x and the y coordinates, you will say here is -2 square root of 3 and -2. Those are your x and y coordinates. By the way, if you know how to handle this, great. If you don't know, there are few formulas. I'm skipping and I'm going straight to the formulas here. X equal r cosine theta and y equal r sine theta. If I want to use x equal r cosine theta, I will therefore say r here is 4, cosine of angle 7 pi over 6. But what is the cosine of 7 pi over 6? Well, 7 pi over 6, you will still have to do this, where 7 pi over 6 is located here, and you will say reference angle, you will say -1, negative square root of 3 and 2, and you will say this is equal to 4 times adjacent over hypotenuse, and you will still end up with the same 2 square root of 3. Same thing with the y, you will say y equal r sine theta. Therefore, you will say 4 sine of 7 pi over 6, which is equal to 4 times, sine here is -1 over 2, and you will still end up with -2. So this is your final answer. Sometimes, like on example 2, you want to convert this from polar coordinates, and you want to convert two polar coordinates. So I have -3 and 4. So let's go ahead and plug in the point -3, 4. -3, 4 will be located somewhere here, where you have this angle. This is -3. This is 4. Using your Pythagorean theorem, you should be able to find the missing side, which will represent your r, and the missing angle, that will be your theta. Once again, you can use the formulas, but let's go ahead and try not to for now. That will be -3 squared plus 4 squared is equal to r squared, or r is equal to 5. That's just the radius, or r. Let's find the angle. To find the angle, I will say tangent of theta. Note that I'm using the two information that were given. Is equal to 4 over -3. So theta itself is equal to the inverse tangent of 4 over -3. So what I would do is I will forget about this now, and I will use Carl and Big Belly, knowing that this is negative and is a tangent. Tangent is the belly, negative is going to be in this quadrant. Tangent, cosine and his brother secant line of negative is in this quadrant, or it can be in this quadrant. Well, you can use your calculator at this point. So because you're looking for this angle, which is in quadrant 2, you're looking for this angle instead based on the picture. So you're going to find the angle and make sure you convert it back to quadrant 2. So you first look for the reference angle. The reference angle here is, you will get 0.927, and of course, because you're looking, the 0.927 is the reference angle, you will go ahead and do 180 minus the reference angle. That will be 180 minus, let's do pi because we stay in theta, minus 0.927. That will give you approximately 2.214. So your coordinates will be r, which is 5, 2.214. Using the formula is also possible. You have the formulas here. Those formulas are there to help you. I will do 2 more problems, and this will be it for our 8.1. Let's convert to polar form. Let's convert to polar form in radians. So we have 3 and -5. The first thing is r is equal to, using the formula, I know it's the square root of x squared plus y squared, and this one will be the square root of 34. Now theta, on the other hand, is equal to the inverse tangent. Once again, I'm using those formulas, but you can always build your own triangle of 5/3, which is equal to 1.03. This is using my calculator, and because we converted to polar form 3, -5, let's figure out what quadrant is located in. 3, -5, if I graph it, 3, -5 is located in this quadrant. So this is the angle I'm looking for. So in order for me to find this angle, I will do 2 pi minus the reference angle. So here I will go back and do 2 pi minus 1.03. Why 2 pi? Because 2 pi is the whole thing. The angle that we're looking for is this, always from here to here. So 2 pi minus this reference angle, the reference angle is what I'm making yellow right now, will give you your angle. So your final answer will be approximately 5.253. So your coordinates will be square root of 34, 5.253. And that is your final answer. I'll go ahead and do 3 also. For number 3, I have 2 and 7 pi over 6. This time we're converting to rectangular form. Alright, the first thing I would do is say x is equal to r cosine of the angle. Remember, the cosine is the x, so it will be 2 cosine of 7 pi over 6, and y will be equal to 2 sine of 7 pi over 6. Where is 7 pi over 6? 7 pi over 6 is located in quadrant 3, which is here. Reference angle is 30, so this is -1, negative square root of 3, and 2. Now, so the cosine here is negative square root of 3 over 2. I'm taking this back down to say x is equal to 2 times negative square root of 3 over 2, which is just negative square root of 3, and y is equal to 2 times the sine, which is -1/2. So your final answer is just -1. So to write it down, you will say is, open a parenthesis, negative square root of 3, comma, -1. And that will be your final answer. This concludes our 8.1 notes. Do not trash this worksheet because this will also be your 8.2 notes.